So we're continuing with examples of trigonometric limits, part 2. This time around, I have limit as x approaches 0 of 1 minus cosine 3x over x squared. What is the form? Let me check. Form, if I plug in 0 for x, I get cosine of 0, which is 1, 1 minus 1, 0, and in the denominator 0, so form is 0 over 0. Now, what do I have? What we had so far is this one, limit of sine of u over u as u approaches 0 equal to 1. There was another formula that we shared, but then again, remember, if you're trying to separate a product, limit of product, both limits have to exist. And if I want to use the limit that I already have involving cosine, which is 1 minus cosine of u over u, u goes to 0, is equal to 0. This one is not going to work because then I have to separate things and I will have something that does not have a limit. So I'm going to not use that. Try to see what I did when I got that limit. I used conjugates. So let's try to do conjugate to switch back to sine. And so how do we do conjugate? What's the conjugate of 1 minus cosine of 3x? That would be 1 plus cosine of 3x. So I multiply top and bottom again. Am I in the?
Yeah.
Okay. X goes to 0 of 1 minus cosine of 3x. Conjugate of that is 1 plus cosine of 3x divided by 1 plus cosine of 3x. The top multiplied together to get 1 minus cosine squared of 3x, and the bottom stays as x squared times 1 plus cosine of 3x. Now, what is cosine of 1 minus cosine squared 3x? That's sine squared 3x. So limit becomes x goes to 0 of sine squared 3x divided by x squared times 1 plus cosine of 3x. So at this point, I'm going to look at this and say, well, I see something that's similar to sine of u over u. If I assume u is equal to 3x. That's one thing. Then I realize it's actually sine squared over x squared rather than sine. So can I do that product rule of the product property of the limits? If I can write it as limits that they all exist, yes, I can. So that's what I'm going to do. So the first thing that I do is I write as this sine of 3x over x, then limit sine of 3x over x, limit 1 over 1 plus cosine of 3x. And x approaches 0, x approaches 0, x approaches 0. Now, what I'm going to tell you is that each one of these limits exists, so the entire thing exists. Hold on. 3x, I decided 3x should be u. Let's make that u over here. Okay. So if that's u, I need the 3x on the bottom, right? I don't have 3x on the bottom. What do? I change the disguise. And then I make it, so I multiply top and bottom by 3. Here I want to have u, and u has to be 3x in the bottom. I don't have it, so I multiply top and bottom to get a u. By the way, limit of 1 over 1 plus cosine of 3x as x approaches 0 is going to be 1 over 1 plus 1, which is 1 over 2. So this is going to be, rewriting it with the, it's going to be limit of u approaches 0 because 3x, as x approaches 0, it approaches 0, of 3, this part is going to be sine of u over u times limit of, again, another 3. This part is sine of u over u, and that part we decided is going to be 1/2. So I get this part, this limit as u approaches 0 is going to be 1 times 3 is 3 That one also, 3 times 1/2, and I get 9/2, right? So this one has some similarity to that, except that in here I had to switch cosine with a conjugate to become a sine. Here, again, we're going to have the same story, except that it's not conjugate. We have to switch to sine, but it's not a conjugate problem. Let's look at this. If I plug in 0 in here, what kind of form do I get? Form is going to be, again, tangent of 0 is 0, and 0 as x approaches 0 is 0. So I have a 0 over 0. What do I know? I know that formula. I know this one. But this is not sine. What do? I use my trig identities. What are the trig identities? Tangent of x is equal to sine of x over cosine of x. So limit as x approaches 0 of sine squared 3x over cosine squared 3x. So I replace tangent by sine of this over cosine of that, but they have to be equal to power 2. So now I have this. Wait, this is fraction in fraction. I don't like it. Let's get rid of that. So basically, I'm going to multiply the top by reciprocal of the bottom, and I get limit x goes to 0, sine to power 2 of 3x over x squared cosine to power 2 of 3x. Numerator times the reciprocal of the denominator. This is reciprocal of denominator is 1 over x squared multiplied by the numerator, and you get this. And so now let's try to figure this out. Wait, one thing. Cosine of 3x as x approaches 0 is going to be 1. Cosine of 3x is not the problem. Where do I have the problem? I have things with sine and x to the power. But here, I want u to be the one inside. So I'm going to remember that. Then the next thing that I remember, I don't want sine squared x squared. I want them to be of power 1. So I separate everything and hope that each one have a limit. And if it doesn't, then I stop doing that. And so I have sine of x, 3x, over x. That's something that we want. We want power 1 of them on top of each other. Then limit as x approaches 0 of sine of 3x over x, and then I have limit as x approaches 0 of 1 over cosine to power 2 of 3x. I didn't make the cosine 1 over cosine of 3x separately. Why? Because this one has a limit y. And so when I plug in 0 in here, I get 1. And it goes, this is going to be equal to 1. Now, I'm not done. These limits are not quite in that format. How do I put it in that format? Inside is u, compare. So I need to have, but on the bottom I don't have u. What is u? 3x. But if I multiply the bottom by 3, I have to multiply the top by 3. Here again, 3x on the top, 3 in the bottom. I just want to change the this, guys. I don't want to change the person, so I have to multiply top and bottom. So this is not different from what I had in blue. So when I multiply by orange, it's not changed from what I had in blue. Now, what do I have? I have limit of 3. This one is u again, of 3 sine of u over u. As x approaches 0, u approaches 0 also. And then the same thing here. And that part we decided is going to 1. Therefore, I will have this part, limit of sine of u over u goes to 1 as u goes to 0. Therefore, I have 3 over here, and I have a 3 over there. So the entire thing is 9. And so we evaluated the limits.